Hello, my name is Abdurrahim. I go by Zain Khan. Today I'm going to do a quick presentation on the field of electrical engineering. On the agenda today is the scope of electrical engineering, so what all falls under the umbrella, a history of electrical engineering, the pressing problems that we have in the world today that might have an electrical engineering solution, an occupational outlook, so what are the prospects of somebody looking to get into electrical engineering in terms of salary, etc. Electrical engineering in Houston is important. Houston is a big city, so there's a lot of resources for electrical engineers here in Houston. And then lastly, we'll take a quick look at what it actually takes to become an electrical engineer. So quickly, what is electrical engineering? Well, engineering itself is the application of science and mathematics to solve real-world problems. And so therefore, electrical engineering is just engineering with a little electronics bent, electricity. The technology of electricity. And so in this presentation, I'm going to take a look at electrical engineering from the perspective of one certain company that I work for. It's called Schlumberger. And so we'll take a look at electrical engineering kind of from that perspective. What do electrical engineers at this company actually do? And it's a good representation of what an electrical engineer might do at any company. So some of the tools of the trade. Tools of trade are important. You know, every profession has its trademark tools. So a doctor has his stethoscope and a mechanic might have a wrench. And so the tools of electrical engineering are the oscilloscope. You've got your voltage on the y-axis and your time on the x-axis. So you can actually see signals as voltage levels over time, which is very useful. You've got your soldering iron. You join two components or two conductors, two wires with a soldering iron and some solder, and you make a permanent joint with this tool here, a soldering iron. Lab bench, a clean, controlled space to build and debug electronic circuits, very important. A lot of time is spent on here. A DMM, you cannot see electricity with your eyes, and so a DMM kind of allows you to see the electricity going through a circuit. Very, very important tool. So back to the company that I work for and the different roles that an engineer might play. One of them is components engineering. So electrical circuits are made up of little components that do certain things, and these little components have different properties. So a components engineer will pick components based on their properties, subject them to different tests, like you'll put them under pressure or high temperature, analyze their behavior, analyze the results of the tests, and then kind of publish your findings to different teams within the company, and based on those findings you can make a good pick of what component is going to work for your application. So very important, components engineering. Design engineering, bread and butter of electrical engineering. You start off by having some kind of problem, some kind of thing that you need an electrical circuit for. You design or you construct a set of constraints, an outcome that you're looking to get, and the constraints that you have, such as maybe the input voltage and maybe the output voltage, or what you want to drive on the other end. You create a circuit that will meet those specifications. Here's a schematic of a circuit, and then based on that circuit, drawing that circuit schematic, you can send that over and have it made as a circuit board. And then lastly, we're going to look at test engineering, and that's actually what I do at Schlumberger, is I work with the test team. And so the team is called EDFT, Engineering Design for Test. And so we'll take those boards that the design engineer has kind of designed and had built, and then we'll run tests through it. This here in the middle is a test station, and it's got a bunch of different equipments for measuring signals and voltage levels and current levels and all kinds of different things. And we make sure before we send it out to the field, where time, money, and resources are on the line, we make sure here at the plant, at the company, that before we send it out, it's actually going to do what it was designed to do. So test is very important, and these roles, an electrical engineer plays all of them. You may have an electrical engineer doing tests, you may have an electrical engineer doing component engineering, and they're across all different companies will have these different roles for an electrical engineer to play. Quick look at history of electrical engineering. Some names here: Tesla, Edison, Faraday, Maxwell. Of course, Tesla and Edison, the most famous ones on this list, and some of what they contributed. Quickly, Tesla, the father of alternating current. Edison, he advocated for DC, direct current. Faraday, Maxwell. Why do these names matter? What is the importance of it? Well, Nikola Tesla and his alternating current, we use alternating current in our power transmission today for all of our homes and businesses. So very important. Thomas Edison, of course, the demand that his inventions created kind of pushed for the electric grid that we have today, the electric power grid. Faraday, Maxwell, kind of more a little bit on the theoretical side. Of course, the farad, the microfarad, or the farad, named after Faraday. Maxwell, kind of the foundations of electromagnetic theory, and all kinds of technology built off of his work. What about the future? Electrical vehicles, EVs, Tesla, Rivian, electric is in the name, so I think that one explains itself. Automated labor, Amazon. If you go to an Amazon warehouse, a lot of it is automated nowadays, and of course, a lot of electrical engineering goes into that. Energy solutions, we all want to go green and save the planet. Electrical engineering will play a big role in that, of course. And then outer space and beyond, so spaceships, and from the big and the small, electrical engineering, digital technology is going to play a critical role in that. And so with that comes, career opportunities. About $100,000 a year for an electrical engineer, and a 3% job growth over the next 10 years, which is a little bit slower than average. But again, with an electrical engineering degree, you have so much knowledge of the fundamentals of electronics and a little bit of physics that you really the world kind of opens up to you. You can explore a lot of different opportunities as with an electrical engineering degree. Here in Houston and across the world, IEEE is the Association for Electrical Engineers. About 400,000 members strong. A&M, Rice, and U of H all have IEEE branches, and if you join them, which you can do as a student, it's very simple, and it gets you access to their social events and their presentations, which could be useful. Quick side note, EPO is a company here in Southwest Houston. If you have time, you should stop by there and check them out. They've got all kinds of electrical components. They do presentations on the weekend of electronics topics. So shout out to Chris Maka over at EPO, a very, very good guy. The road ahead. So if you want to get into electrical engineering, you're going to need a 4-year degree, Bachelor's of Science of Electrical Engineering. It's important to note that there's only one electrical engineering degree, and there's other degrees that sound like it, but they're not electrical engineering. So if you want to become an electrical engineering and make that pay, you need to make sure that you're getting a 4-year Bachelor's of Science in Electrical Engineering. Experience, the more experience you have, the better. Once you actually start working on things, you're going to find that it's a lot different from just kind of what you study on paper. So it's very important to actually have some hands-on experience, debugging circuits, taking signal measurements, etc., etc. Quick recap, electrical engineering is the branch of engineering dealing with electricity. Within electrical engineering, there are many roles that an engineer can play. It looks like many different things for many different people. It's had a huge impact on our world today. Again, electric vehicles, automation, it's limitless. Employment in electrical engineering is very, very lucrative, especially the more specialized you get. And then again, EE typically requires a 4-year degree in electrical engineering. Here's some of the resources that I used, and that's the end of my presentation. Thank you for listening to my presentation, and have a good day.